point. All right, we're going to be talking about keywords of equations. So if I said a number times 3, that would be a multiplication problem, right? Because the word they use is times. So for a multiplication problem, a keyword would be times. Or if they said 14 more than X, that would be a what type of problem? Addition, because more than is a keyword for addition. So today we're going to be talking about what are those keywords that make our expressions or equations. Because you're going to be given scenarios that you'll have to write an equation about, or you'll have to solve an equation for. And if you don't know what those keywords represent, you're not going to be able to make the equation to solve. So let's start with addition. I want y'all to just tell me as many keywords as you can think of. Plus, sum, add, greater than, more than, older than, gain, that's a good one, raise, deposit, increase by, Shania, ascend. All right, those are some good ones. We'll come back to addition if you think of some more. Now, what about subtraction? Difference. Withdraw. Less. Minus. Descend. Decrease. Take away. Less than. So less and less than in an expression, they represent the same subtraction, but the way you subtract is different. Yes?
Wouldn't you see when you're like in third grade and subtraction, at the end it says how much more blah 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 blah. Wouldn't it say, because they would use that how much more?
Yeah, so that's basically difference. Yeah. Any other words you can think of? Decrease by. All right, let's go on to multiplication. So times, multiply, product, up would be plus, of, yeah. If you say that it was twice as much, that's multiplying by 2. So twice. Or double the amount. Double. That's multiplication. Or triple. Those all mean multiply. We just know exactly what number we're multiplying by. I think that covers most of our multiplication. What about division? Group. Quotient. Divided by. What about like 1/3? Yeah, 1/3. You're going to divide by 3. Yes. Share could be one, but it depends on the content of the problem. Because you could mean share and you multiply, or share and you add, or share and you subtract because you're taking away what you have. So it depends on the context of the problem. Collage.
What about like fraction maybe?
Okay, so a fraction of. Yeah. So a fraction of. Yes.
Can like split even?
Split. Split into 2. Yeah, that's a good one. Another word for split is half. A good one for yours, Andrea, instead of share, maybe divided among, because then you're Tatiana.
Wondering if distribute can be a multiplication, but division word.
When I distribute, usually I'm thinking of multiplication.
Yeah.
Any other words y'all can think of? I think we got a pretty good list. So now we're going to go on to using our list. Let's think of some different situations where we have to write an expression. So I'm going to give you a short little expression to write, and then we're going to make an equation or an expression. So the first one, 25 decreased by a number. Now, do we know what number they're talking about? No, so we can put what? X, a variable. So a number we're going to represent as X. And then we know we're dealing with 25. And decreased is a key word for subtraction. So 25 minus X. Now I want us to evaluate if X is equal to 20. So what would I do with 20?
You would replace the X with
So I would substitute 25 minus 20 gives me 5. So if 25 is decreased by a number, 25 minus X. If that number is 20, 25 minus 20 is 5. Let's do another example. The sum of a number and 8. So tell me my keywords here. So the sum of a number, what number do we want it to be? So we can use any variable. Let's use n of a number and 8. So we have, what is the sum going to be? Adding or subtracting? Adding. So we have n plus what? 8. Now let's evaluate if n is equal to 14. So we're going to take this, we're going to plug in what? 14. So 14 plus 8 equals 22. Let's do this one. This next one is a little tricky. It's easy, but it's just, you got to know where to put the numbers. So 15 less than a number. So what's my key word here? Less than. And we have 15 and a number. We'll call this number y. So if 15 less than a number, are we going to be subtracting y, or are we going to be subtracting 15 from y? 15 from y, because we're saying 15 is less than this number. All right? So whenever you have less than, you're going to put this number second. Okay? If you have more than, you put that number before it second. Less than or more than, you put that number second. So we have y minus 15. And so let's imagine y is equal to, let's do 5. Let's see if we can remember our integer rules. So y is equal to 5. So 5 minus 15 is what? Negative 10. All right. So let's do an expression. Yes, Kalash?
So when y have to be greater than 15, because it says 15 is less than,
they're saying 15 less than a number. So a negative 10 is less than 15, right? So you're not thinking about, we're past that. We're past thinking elementary where we can't have a number subtracted from another number because it's not big enough. All right? We're dealing with integers, positives and negative numbers. So you can get a negative answer. All right? So it doesn't have to be a bigger number first. We're past that. Okay? All right, let's do another example. This one we're going to have more than one variable or more than one. All right, 14 less than the product of 4 and a number. 14 less than the product of 4 and a number. So key information. So we know less than. So that less than is going to tell us to subtract. Product is another key word. Product is going to tell us to what? Multiply. And we're dealing with 14, 4, and a number. So what do we want our number to be represented by? What variable? A. All right. So 14 is going to go second because it is less than whatever this is. So I'm going to be subtracting 14. And the product of 4 and a number is going to be what? 4 times A. So 4A minus 14. So there goes our product of a number and 4. And this is less than 14. So now I want you to evaluate if A is equal to 6. So solve for the expression when A is equal to 6. Israel, what do I need to do? All right, 4 times 6 minus 14. 24 minus 14. All right. Thank you, sir. All right, let's do another example. Four less than the product of 9 and a number. I want you to try that one on your own. 4 less than the product of 9 and a number. All right. Keywords. Less than. Product.
Number.
4, 9, a number. What is our number going to be represented with? All right. So we know we have a product of 9 and a number Q. So we have 9Q. 9 times Q is 9Q. And we have 4 less than the product of this number. So 9Q minus 4. So I want you to plug in, what if Q was equal to 2? Check your answer. So we have 9 times 2 is 18. 18 minus 4 gives us 14. I want y'all to try to rewrite an expression. So 36 minus 3x. So I want y'all to write this in words using your keywords. We have 36 minus 3x. So using how they have 4 less than a product or whatever, write that in words. All right, somebody help me. Bren?
I said 36
36.
minus the product of 3 and x.
All right. So I will write in a second. 36 minus the product of 3, and a number. 36 minus the product of 3 and a number. That was perfect. Israel?
So I put the product of 3 and x less than 36.
Okay. The product of 3 and x less than 36. Emanuela?
I put the difference of 36 and the product of 3 and a number.
Perfect. The difference. Hold on, say it again.
The difference of 36 and the product of 3 and a number.
Of 36 and product of 3 and a number. Kalash?
Like, I did the same thing as Israel, except I did, instead of putting an S, I put an
And a number? Yes. So, and a number. So, all of these are good. And I do agree with you, Kalash. Make sure we say and a number. Because you're making it so that you can put whatever variable you would like. All right? Let me give you another one to make an expression. 60 divided by 5x. Divided by 5x. So write this expression as a phrase. Collage, what you got?
I put the product of 5 and the number divided by 60.
So is this 5x divided by 60 or 60 divided by 5x? So we would have to put, yeah. So we can't say the product of 5x, the product of 5 and the number divided by 60, because then that flips around the problem. What's another way we can say it? Shania?
60 divided by 5 and the number.
60 divided by divided among 5 and a number. Bran?
I took the quotient of 60 times 5 and the number.
The quotient of 60 and 5 times a number. Anybody else wrote anything different? All right, those sound good. Israel?
I put 60 divided by the product of 5 and the number.
Okay. 60 divided by the product of 5 and a number. Anybody did anything different? All right. Let's try another problem. All right, I'm going to read this one to you. So you don't have to write it, but I do want you to write the expression. Kendra completed the homework her math teacher assigned, and she also decided to do 5 extra problems. Write an algebraic expression to show how many problems Kendra completed. So now they're not saying a number or something that you need to solve for, but they're giving you some information. Your unknown information will become your variable. So let me read it one more time, then I'm going to ask, what is unknown? Kendra completed the homework her math teacher assigned, and she also decided to do 5 extra problems. What is unknown here?
The homework she assigned.
The amount of problems on the homework that was assigned. So what are we going to name the amount of homework assigned? So, amount of homework problems, we'll label H. So H is the amount of homework problems. And we know that she did how many additional problems? 5. So our expression will be H plus 5. So if we know how many homework problems was assigned, we'll know how many problems she did in total. Let me read another one. Bradley's mom bought him a shirt yesterday. It was on sale, so she saved $8. Write an algebraic expression to show how much Bradley's mother spent to buy the shirt. So, I'm going to read the first part one more time so you can tell me what don't we know. Bradley's mom bought him a shirt yesterday. It was on sale, so she saved $8. So what do we not know?
The cost of the shirt.
The cost of the shirt. What do we want to call the cost of the shirt? C. All right, so C is going to be the cost of the shirt. And I think another word you can add to your list for subtraction is saved. She saved. How much did we say she saved? $8. So she saved $8. So we're going to have the cost of the shirt minus what?
8.
Hector? Seat. Now. All right. Moving on. Let's do another one. Vivian saw great packs of stickers with 25 in each pack. So she decided to buy several packs. Write an algebraic expression to show how many stickers Vivian bought. So what do we not know? The packs she bought. So what do we want to call packs?
P.
All right. P is for the packs of stickers. And this is another word we can add to our list. Each. Each is a really good word for multiplication. Each bag has this. Each tray has this. 25 cents each. Yeah. All right. So P is for a pack of stickers. And each pack has how many? 25 stickers. So we're going to multiply 25 times. So when we find out how many packs she got, we'll know how many stickers she got in all. All right, let's do another one. When Jeff went shopping, he bought 20 new DVDs. Then he decided to give a few to his brother. Write an algebraic expression to show how many DVDs Jeff will have left. I'll read the first part again. When Jeff went shopping, he bought 20 new DVDs. Then he decided to give a few to his brother. What do we not know?
How many he gave to his brother?
All right, so what are we going to call that?
F. F. Oh, she put F.
All right, F is representing the few he gave to his brother. Few DVDs given to his brother. And we know that he had 20 total. So we are going to do what operation? Subtract. Because he gave them to his brother. And we're subtracting F. And he had a total of 20, so 20 minus F. All right, for the remainder of these problems, I'm not going to go over them. I'm going to read them out to you. You need to name the variable, okay? Name the variable, so like the DVDs, we named F. The packs of stickers, we named P. The cost for the shirt, we named C. And then we wrote our expression, all right? So I'm going to give you a couple of examples, and you're going to find your answer on your sheet of paper, all right? I want y'all to do this on something you can give to me. So I'm going to give y'all 30 seconds to get a half a sheet of paper, because this is going to be your exit ticket. 30 seconds. 20 seconds. Ten seconds. 4, 3, 2, 1, 0. First problem. Yesterday, Fran bought a bag of lollipops to share with her 3 friends. Write an algebraic expression to show how many lollipops each friend will have if they share the lollipops equally. So yesterday, Fran bought a bag of lollipops to share with her 3 friends. Write an algebraic expression to show how many lollipops each friend will have if they share the lollipops equally. So this goes back to when Andrea said share. This is a very good context of this problem. We are wanting to share, so you need to figure out what operation are we using. I'll read it 2 more times in case you didn't get it. Yesterday, Fran bought a bag of lollipops to share with her 3 friends. Write an algebraic expression to show how many lollipops each friend will have if they share the lollipops equally.
I have a question.
I don't want the answer.
I have a question.
Yes, Israel?
Is it her and her friend?
Yes. Yesterday, Fran bought a bag of lollipops to share with her 3 friends. Write an algebraic expression to show how many lollipops each friend will have if they share the lollipops equally. All right, next problem. Y'all need one more second? Okay, I'll read it one more time and then we're moving on. Shh. Yesterday, Fran bought a bag of lollipops to share with her 3 friends. Write an algebraic expression to show how many lollipops each friend will have if they share the lollipops equally. Next problem. George dog loves doggy treats, but George knows he will give her too many. George has decided to give her 3 fewer treats than normal each day. Write an algebraic expression to show how many treats she will get each day. George dog loves doggy treats, but George knows he will give her way too many. George has decided to give her 3 fewer treats than normal each day. Write an algebraic expression to show how many treats she will get each day. I'll read it 2 more times and then we're moving on to the next one. George dog loves doggy treats, but George knows he will give her way too many. George has decided to give her 3 fewer treats than normal each day. Write an algebraic expression to show how many treats she will get each day. Make sure you're defining what is unknown, just like we did on the other problems. P for the pack of stickers. C for the cost of the shirt. What don't we know in this problem? George dog loves doggy treats, but George knows he gives her way too many. George has decided to give her 3 fewer treats than normal each day. Write an algebraic expression to show how many treats she will get each day. Okay, I'm moving on. Krista ran 20 miles last week. This week, she again needs to run 20 miles plus several extra miles. Write an algebraic expression to show the total number of miles she plans to run this week. I'll read it again. Krista ran 20 miles last week. This week, she again needs to run 20 miles plus several extra miles. Write an algebraic expression to show the total number of miles she plans to run this week. Read it again 2 more times, then we're going to move on. Krista ran 20 miles last week. This week, she again needs to run 20 miles, plus several extra miles. Write an algebraic expression to show the total number of miles she plans to run this week. All right? So think about, she's run this amount. What do we not know? What are we going to do to put those together so we can find her total? All right, number 8. Or not number 8, number 4 in your case, or 3. Paul has a baseball card collection that he has decided to give to his 4 brothers. He plans to give each brother an equal number of cards. Write an expression to show how many cards each brother will receive. I'll read it 3 more times. Paul has a baseball card collection that he has decided to give to his 4 brothers. He plans to give each brother an equal number of cards. Write an expression to show how many cards each brother will receive. So think about your identifying what is unknown and you're naming it, and then you're going to write your expression using the operation you think will suffice for this problem. So Paul has a baseball card collection that he has decided to give his 4 brothers. He plans to give each brother an equal number of cards. Write an expression to show how many cards each brother will receive. All right, last time, and then y'all are going to have to start wrapping things up on your paper because it's going to be time to go. Paul has a baseball card collection that he has decided to give his 4 brothers. He plans to give each brother an equal number of cards. Write an expression to show how many cards each brother will receive.